Hi everybody, I hope you all are having a great conference. It's an honor for me to speak at Laracon EU. It's a virtual event, but I hope that at the next edition of Laracon EU we all will get to see each other in person again. This talk will be about event sourcing in Laravel, and we'll be going about this in a very practical way. So if you've been meaning to get started with event sourcing, this is the talk for you. I am Freek van der Herten. I'm active on Twitter like most of you. My handle is Freek Meurze. I work at a company called Spatie. I also have a blog, freek.dev, where I talk about modern PHP and Laravel development. Together with my buddy Matthias, I've built an uptime tracker service called Odir. And together with my team at Spatie, I've built an exception monitoring service, especially built for Laravel applications called Flare. Now, before heading into the wonderful world of event sourcing, I want to say a few words about the open source efforts that my company Spatie has been making these past years. On our company website, you'll find a page where we list a lot of open source packages. Mostly they are meant to be used in a Laravel applications, but there are quite a few PHP framework agnostic ones there as well. They've been downloaded now for over 100 million times, and this gives me great joy. I'm pretty sure there's something there for your next project, so be sure to take a look. And with that out of the way, let's talk about event sourcing. This is what we are going to do during this talk. I aim to keep things very practical, but we need a little bit of theory first. After that, it will all be demos, and I will demo projectors first, and after that, I'll demonstrate something that I found something very hard to comprehend when I was learning event sourcing myself, and that are aggregates. Now, let's start with the theory. In a traditional application, you're most likely going to write some data inside of a database. And when you are going to update that data, then you are going to overwrite old data. And that old data, it can't be accessed anymore. And backups don't count because your application logic won't make decisions based on information that is inside the backups. So this is what it looks like in a schema form. It's very simple. Your application will write stuff to the database, in this case value X, and when there's an update, you write value Y, and value X is just being overwritten here. In an event-sourced application, you will go about this in a different way. Instead of writing directly in the database all the time, the application will fire off events. And those events, they will get written in a dedicated store. And in the most simple case, that dedicated store is just a simple database table called events in your database. Those events, they are passed to consumer classes that create projections, and a projection that is just a piece of state. And I've mentioned aggregates, but I'm going to leave that concept off for now. We'll just concentrate on the projections. So this is what that looks like in a schema. So your application, instead of writing to the database directly, it will fire off events, and those events, they will get recorded inside of a data store or an event store, and in most simple cases, this is just a table inside of the database. Using those recorded events, you can build up a piece of state, and that piece of state is called a projection. That projection is being constructed by a consumer class, and the type of consumer that creates a projection is called a projector. Now, you're not bound to only have one consumer inside of your application. You can have multiple consumers. And when you create another consumer, it will get fed all of the events that were recorded. So it builds up state. And when new events comes in, it will be used to feed all the projectors inside of your application. So those projectors will be kept up to date using recorded events. Now, I know that sounds all a little bit heavy. I promise it will become a little bit more clear when we dive into the practical example. Now, when would you need an event-sourced application with projectors? When your application has strong auditing requirements, when you want to know how a certain state became in that state, then event sourcing is good because you get all these little bits of information that tell you how your application got in a state. Event sourcing also shines when you want to create reports that you don't know ahead of time that you need. So when the business says in a couple of months, hey, we needed a report about things that happened in the past, then you can just create another projection. You can feed it the recorded events, and then you have that extra report. With event sourcing, you can also record the unhappy path. This is something that can be done with aggregates. I'll talk about that later. But what you should keep in mind is that when you choose for event sourcing, that there is some setup required to get all of this running. But if you are using Laravel, then you will be happy to know that my team and I have already created a package that can get you quite a long way. That package is called Laravel Event Sourcing, and it provides aggregates, projectors, and reactors. And it's all beautifully integrated into Laravel. And when you know the basics of event sourcing, it's easy to get started with. But we've already talked a lot. I want to show you things to make you feel how it works. So let's do that now with a demo. Let's head to the browser. I've already prepared a little application called Larabank, and Larabank is a very simple application. You can have an account. I'm going to create one now, and it can have a balance. So I'm going to deposit some money here. When I take a look at the database of this application, it's very simple. We just have an accounts table. We have my account here. It has a balance of 50, and let's withdraw some money. And now the balance is minus 350. If I refresh here, we have minus 350, but we have no idea of how we reached this number. We don't have any recording of the transactions of the history. We only have this number. Now I've built this application also using event sourcing. So let's maybe look before we head into event sourcing to the traditional application on how it was built. So we just have an account model. When we in the controller do an update and it is about adding money, then we just update the balance in our model. If we want to subtract money, we're just going to take some amount of the balance and just save the model and be done with it. And that's everything. Now, like I've said, I've recreated this application also using event sourcing. So Larabank Projectors is a Laravel application where I've already pre-installed our event sourcing package in. Let's take a look at the application in the browser. So you can see it looks just the same. So I can open an account here as well. And let's deposit an amount, and let's also withdraw an amount. And let's take a look at the database of this application. We also have an accounts table here, and you can see that we have a balance here as well. But this table is actually a projection, and I'm going to show you in code on how we implement this. What should be of note is that we also have a stored events table in this application. And here you can see that everything that I've just did is stored as an event. We've created an account, and we've added some money, and we subtracted some money. So using these events, we know how we reached this balance. So let's take a look at how we implemented this. So in our accounts controller, we have our update function. If this is about adding money, then we are going to call a function called add money. But add money itself, it will not update the model directly, but it will fire off an event called money added. Let's take a look at the event itself, or maybe let's take a look at what we pass here. We pass a UUID here, and this is basically how we can determine about which account we are speaking. This is an identifier. So for this account, we are going to add this amount. If we take a look at the event itself, it's very simple. It just has these two properties. And this event, it extends should be stored, which hints to our package that, hey, this is an event that should be stored and should be passed on to other projections or other projectors. With, if you take a look back at the controller, we have subtract money, and here just the same thing happens. We fire off an event money subtracted, just those properties, and it extends should be stored. Now in this project, you also see that we have a folder called projectors here, and we have here an accounts projector. And this accounts projector, it is responsible for building up that accounts table that we just saw. So here, when we have on money added, or when this projector hears that money added event, it will retrieve the account from the event using that UID, and here we will update the balance. And with money subtracted, it is just the same thing. So let's drive that point that this is calculated data. I'm going to go to my seeder here, the database seeder, and I'm going to seed some more data. So I'm going to migrate the entire database. Oh, what do we have here? Unexpected token. PHP, how does it even work? Let's do that again, like that. And now we should have a lot of accounts and a lot of transactions here. If I take a look at the UI, you can see that, yeah, we have some more numbers here. Now, because I have all these stored events, I can just recalculate the entire accounts table if I want to. So I can just remove these ones. And the package has a command called replay, which just replays all the stored events to the projectors. So let's do that now. We're replaying all these events. And if I refresh here, we get our data back. And if I refresh here, nothing should have changed because it should have been calculated just the same. And sure enough, nothing has changed. It is just here. Now imagine that you're working on this project and that there's like a new requirement coming in, like we need to know all the transaction counts of all these accounts. Which accounts were the most active ones? Now, because we have all these events, we can easily do that. We can create another projector after the fact to just calculate that data of using all the stored events. So I'm going to uncomment this. And you can see here that this projector class, it extends projector, which is provided by the package. By the way, the accounts projector also extended projector. I forgot to show you that. And here, what this projector does is when it hears money added, it will create a transaction count object. So it will just call record transaction count for the account for money subtracted. It will do just the same thing. And what we do here is we will just, or maybe it's just easier if I just show it to you in the database. Transaction count, just the email of the account, and just the count here of the number of transactions that were performed. So let's replay all events again. And now that other transaction is just listening for that. So let's take a look. And here we have all the counts being calculated. And we also have a view in our user interface to just show you the counts. And if we take a look at the controller of that extra view, then you can see it can just make use of that model that we have just created. So in a traditional application, to get these counts, you probably would do that in SQL, and it would be like a heavy kind of SQL. But in an event sourced application, if you want to see derived data or like difficult to calculate, to live calculate data somewhere in a view, you can just create a projector for that view, and then reading that data becomes incredibly cheap because you've just pre-calculated the state of that view. So yeah, that is projectors. Let's talk about reactors, and this is a reactor that I've already created. So a reactor is also like a projection or a projector, an event handler, but a reactor only fires when the original event is being fired. So this won't be executed when events are being replayed. So what this reactor does is that when a large amount of money is being added to an account, it will mail the FBI. Of course, not the actual FBI. If we take a look at the code, if there's like a small amount coming in, we're not going to do anything, and otherwise we are going to send that mail. We are only, of course, going to do this when the original event fires and not when the events get replayed, because we only want to have this mail when this actually happens for the first time in our application. And we can replay the events as much as we like, but we don't want to notify the FBI when we replay the events. We only want to notify them when the original event happens. So that's what you can do in a reactor. And shortly said, a reactor is for handling side effects of your code. So let's take a look that this actually works. I've got a little application here that shows me all mails that are being sent in this application. So if I do a low amount, then no mail is sent. If I do a big amount here, then you can see that the reactor actually fires and a mail will be sent to the FBI. So those are reactors. Let's head back to the presentation and talk a little bit more about aggregates. When learning event sourcing myself, I found that aggregates were one of the most difficult things to understand, so don't feel ashamed if you don't get it right away. So using an aggregate, you can model a business process. And we are going to model a simple business process here. We are going to build up the example of accounts. We are going to say that an account cannot go below 5,000. And when somebody tries to go below 5,000 3 times in a row, we should propose a loan to that person. So this is how it works. So our application, it will ask the aggregate subtract 1,000 from the account. Now the aggregate, it will be reconstituted from previously stored events. I'm going to repeat that later. It's more clear when there are more events. So hang on with me. We are going to take a look in the stored events table to the events of the UID of the account, and we will use that for aggregate root. It's a little bit more complicated, but bear with me that this is now the account UID. So the first time there are no previous events, and the aggregate, it knows like the balance is 0. So this command that we give to the aggregate, it's okay. And the aggregate will say there should be an event stored, money subtracted for the amount of the command here. So what happens is that event will get persistent stored events, and the projector, it will also record that event, and we will have minus 10,000 or minus 1,000 in our projection here. So what happens when we want to subtract 4,800? which would go our balance, which would make our balance go below 5,000. So the first thing that the aggregate is going to do is, for the account that this command is given, it will retrieve all the events, and the aggregate root will be reconstituted from all these events here. It will see, hey, we have 1,000 here, and we have 4,800 here. That's if we would allow this, we would go below the minimum of the account. So we're not going to create or fire an event to subtract money. We are going to record that the limit was hit, and we are going to persist that event. So this is what it would look like. So we would store the limit hit, and we could even store the amount that a user tried to subtract. And of course, in our projector, we are not going to do anything because we have rejected this. Our balance is still at 1,000. So let's see what happens if we do that again. So when we subtract that again, we are going to reconstitute the aggregate root from disk. We have money subtracted, limit hit. This would also go below our limit, so we are going to record another limit. And the third time we are going to do this, we are going to retrieve it. We have money subtracted, 2 times limit hit. Here we are going to record limit hit, but the aggregate root sees, hey, we have limit hit 2 times here. I'm going to fire it again, and now if I have limit hit 3 times in a row, and I'm also going to record a loan proposed event. And we could have a reactor that could send a mail when the aggregate root fires off that event. That's how it works. So an aggregate root reconstitutes itself from disk every time to make decisions based on the past. Okay, that's the theory. Now let's see it in action. Let's go to the browser. So here you can see that I've rebuilt Larabank using aggregates, and I've actually implemented the business rules I've just set. So we can't go below 5,000, and if somebody tries to go below 5,000 3 times in a row, then a loan proposal mail should be sent. So let's try and see if that works correctly. So let's add some money and then try to go, let's first try to withdraw 5,000. Now we're close to being in the minus 5,000. Let's also keep look at the mails that are being sent. Let's try to go below 5,000. And we can't, we get an exception, but no mail is sent. Let's do it a second time. No mail is sent, only the exception. Let's do it the third time. And now we can see that a mail was sent for a loan proposal and the exception was thrown. So let's take a look in PHP Storm at how this is implemented. So in our controller, we are going to retrieve the aggregate root for the account UID here. So we are going to take a look at which events there already were for this aggregate root. And maybe before explaining the whole thing, let's maybe take a look at the stored events that we had with our previous demo in the browser. So we had account created, money added, money subtracted. We hit the limit 3 times, and we had that more money needed event, which triggers that mail in a reactor. Okay, so using this method, we are going to first retrieve the account aggregate. In that money added method, we are going to record a certain event, money added, which will trigger our projector. And this record that, it won't release the events right away. That will be done when the aggregate root is persisted. A persist means that all the events that an aggregate root would like to fire will actually fire then. We also have subtract money here. And here we have our extra business rules here. But first, let's take a look at what those apply methods actually do, because those apply methods, they are kind of important. I'm going to remove the database here and rebuild it from scratch. And you can see that with add money, we also have apply money added. This is like apply and then the name of the event. And when an aggregate root is being reconstituted, then all the past events will actually go through this method, and we can use those methods to build up an internal state that we can use to make decisions on. So let's add something here so we know that this is being called. So that function ray just sends that string to that little window here. So let's clear it. Let's apply some things here. So let's open up the account here. And when I deposit some money here, then you can see that we have that apply here going on when the aggregate root is being reconstituted. If I add some more things here, you can see that we not only get it from the current request, but also from all the previous ones. So all these events that we have here in our table, every time that we call every time that we call, where is it? Every time that we call retrieve on the aggregate root, all those events will be passed to the aggregate root, which will allow us to build up the internal balance here. Okay, let's see what happens when we try to subtract some money. If we subtract some money, then this is being done in the aggregate root. So the first thing that we are going to test is has sufficient funds to subtract a certain amount, which we get from the controller. And here you make a simple calculation with the internal state of our aggregate root minus the amount, and that can't go below the limit here. The limit is also being defined here at the minus 5,000. If we have enough money, then we just are going to record that money subtracted event, which will trigger our projection to actually subtract the amount of money in the accounts projection. If there is not enough money, then we are going to record an event account limit hit, and we are going to persist that event, and we are going to throw an exception which will make that error message that you saw appear. Now, account limit hit also has an apply function here. So here we can see how many times that the limit was hit in a row, and if that limit in a row was higher than a certain number, that is being checked in needs more money. So if that limit hit in a row is higher than 3, then we will record an extra event called more money needed, and we will persist that one as well. And that more money needed event, that will trigger our reactor. And here you can see that this reactor, it responds to more money needed, and it will send a mail. And that is how all of that works. I can imagine that it's a little bit confusing because it's very high paced here. Let's head back to the slides and start wrapping up. On our site, we have extensive documentation about our package. And I know that some of the examples here, certainly the one of the aggregate root, was very fast-paced. Those examples are actually also being explained in the documentation in the Getting Familiar with Event Sourcing section. So if everything was a little bit too fast for you, read these articles at your own pace. Our package is not the only PHP package to implement event sourcing. There are a couple of other ones as well. And one that I want to mention is Event Sauce by Frank de Jonge. Frank is also the guy that brought you the excellent Fly system. And Frank once said, and I totally agree with this, is that event sourcing makes easy things harder and the harder things easier. If you're going to use event sourcing for cruddy things, you'll likely have more work than usual. But if you have an application where you need to make decisions based on the past or want to build state based on the past, then event sourcing is a natural fit. Throughout this presentation, I took some liberties to explain things and cut some corners, but if you want to know it in a very profound way, I can highly encourage you to view the Event Sourcery course by Sean McCool that you'll find at that URL. The Larabank examples that I've shown you are available in these repos, so you can try those out yourself. There's one more thing that I want to tell you. Event sourcing is such a cool subject that we at Spatie want to create a course about that. We're currently building an enormous event sourced application for one of our clients, and we want to share that knowledge with you. So in this course, we will show you the basics of event sourcing, the best practices. The examples will be Laravel specific, and you'll also get access to the source code of an event sourced card package that you can use in your e-commerce project. And we expect this course to be ready by mid this year. So that's everything that I have for you. Head over to the Laravel event sourcing docs if you want to know more. We're currently also having a promo on all our paid products. You'll get 25% off if you go to spatie.be/products. I hope that you have enjoyed this presentation and that you enjoy the rest of the conference. Take care, and until next time.